Hello class, my name is Albert Santiago. I'm going to brief you about the software requirement specifications for the highway autonomous vehicle. So this is the summary of that project. A little bit of myself. Well, this is me in the picture holding a big iPad. Uh, so I have a bachelor degree in electrical engineering, also a master degree in signal processing and control, and I'm currently working on my second master degree in software engineering. Um, I'm very weak in software, so I decided to do something about it, and this is it. Um, I have 13 years of experience in the defense industry, and normally I work with software projects, and I interact with the software people a lot. So that's why I'm working on this degree. Okay, already. So for formulating the requirements and specifications, uh, of course, we were suggested to use uh, several techniques, and this table and the next slide summarizes those techniques that I use. So we started with the definition of the problem. This allowed me to identify root causes of the problem, identify the system boundary, constraints, and the stakeholders. Uh, I also use a frame diagram, which allowed me to specify distinct domains and connections between them. So most of the non-functional requirements came from this portion. Uh, also, I use a context diagram. This gave me a high-level description of the system and how the system interact with the actors. The ERD, or entity relationship diagram, provided me with some information between data entities and provided specifications of their attributes and relationships. The use cases, of course, provided me with the actors and the system functions and the interaction between them, uh, and it also provided me with some abnormal and misuse cases from where some requirements came from as well. I used decision tables, and it provided me with the cause and effect specifications for some of the decision logic of the system. Uh, I also use activity diagrams. Provided me with kind of the graphical flow, of course, of the required data for flow continuation and stop point. Uh, use the sequence enumerations. These are specifications on state machine reflecting enumerations, the stimulus and the response. The user interface prototype uh, allowed me to build a Credo matrix. Uh, and also, I complemented the project doing a hazard analysis. Uh, this provided me with specifications on safety measures. And after I did that, I did some risk assessment and mitigation plan. Uh, we also included a sequence diagram. It kind of provided me with kind of the inner communications between actors and subsystems in a sequential order. Um, so this is an example of the fault tree analysis. In here, the main goal was what causes or the potential causes for an accident or damage. So this is what we want to prevent. This is what we don't want the system to do. And this is a series of ands or ors of potential causes for that, and for each of them I did a kind of a mitigation plan from where a lot of the requirements came from as well. This is the frame problem. I decided to divide the problem in 3 domains or main domains. We have the main domain is the controller here, which is the system computer doing queries about the external environment. So we have the navigation environment as well as the highway environment. This is where the traffic, all the objects are. And the navigation environment is kind of the communication between the satellite and the GPS tracker to provide the necessary information to the controller or the main system computer. Okay. So also this slide shows the system ERD. In here I took an approach of providing an interface to the driver or user about the trips that the vehicle has taken, for example, or is currently taking. So we got the current trip as well as previous trip, and each data entity provides information about the route, distance, time, selected exit, for example. But also it provides some kind of interface to the commercial database, in where we can this will allow to update the software system in the vehicle, so we can tell which software versions we have installed in the past and which software version are currently installed in the system. So it's kind of a somehow scope to just those areas. This is kind of the use case diagram. We have as actors the driver, the commercial database, other vehicles, pedestrians and objects, and I added the law enforcement, kind of to comply with some regulations as well. The next slide is the activity diagram, and I was saying this provided me with some sort of sequential as well as what kind of data do I need to proceed to the next level or next step. So in this case we have 3 swim lanes, and where we have the driver, the system, as well as the environment. And this particular red node here is kind of an abnormal case in where the driver decides to cancel the system while it's in function. Okay, so I'm not gonna go in detail, but it kind of shows you from the point of where the driver start the system will check if it is ready. It will have to do some kind of cross check with the satellite system, and the GPS tracking as well, probably other sensors, and these are some decisions in where the system, when it's driving, it will acquire some information about how far it is from the desired exit location. Okay, I'm assuming here that you know a little bit of the description of the system. So this is the data flow diagram and it's kind of a little bit spaghetti diagram, but it's not. It shows this system boundary as well. It has the actions inside the system and what kind of data it needs from each of the actors outside and internally. Okay, so this flow diagram shows examples of some internal databases, the transformation of the data to acquire or update the database from from actors. So it provides, and again, it shows kind of the information needed to do certain actions represented in these nodes here. This is the sequence enumeration that I came up with. It's very simple. Basically, I'm going to start with power off. We can power on the system. The drivers inputs a valid high weight exit, and also it has to input a valid speed of the vehicle. If the speed of the vehicle is not valid, it will go back to wait until for that queue. But also, once we input a valid exit and a valid speed for the vehicle, the system is ready to do autonomous driving. And the user will have the option of putting the system in some such of idle mode or cancel or stop the process and bring that to power off as again. Okay, so these reflect some of the outputs of when we have a query or an action or a stimulus. This table here, this is the legend showing what kind of outputs we get for each of the commands in this table as well. Okay, this is the user interface prototype I came up with. In here, it allows kind of the driver to power on the system or power off the system. The display will show me the miles to go and the minutes to go, the selected exit, the selected speed for the vehicle. Kind of has some navigation display, and as well this bar shows the current status and action of the system. If the system decides to, for example, pass a vehicle, it will display that in here, kind of to let me know, hey, I'm steering the vehicle, so don't freak out. So the user also have the option of choosing the history. There is a history button in where we can see previous trips and the current trip information, and also has a button for about. This is where we interface with the commercial database and seek for information of what kind of map version is installed in the system and so on. Okay, so this is pretty much a summary of all the techniques used. This slide summarizes the requirement specification summary, how many of them I have identified. So I have identified 83 functional requirements and 16 non-functional requirements. Okay, and this table here shows the source of of the requirements. In terms of the model or technique used for that, and on the top row header, I can see from where that requirement came from in terms of, oh, is it a hazard analysis? Did it come from the government regulation, for example? And you can see that this column shows that most of them are due to some engineering judgment, what I call here. Okay, so this is it. I can conclude that the used techniques allowed me to formulate the requirements for this system. I have identified requirements. I'm sorry, the identified requirements specify the main components and behavior of the system and its operating environment. The requirements characterize the responses to unexpected events, and the requirements reflect any constraints on the implementation. This was a fun project, I have to say. I like it very much. So I wish you luck in your career. Thank you for your time.